Okay, we are back. Wonder if anyone was able to figure out that the music from the teas that I played at the end here. Does anyone know what opera this is from? Or... So if you know, let me know tomorrow in class. Okay, you can get a piece of candy. Sugar-free though. So let's see. We're going to do example 4. So find the sum of 2 plus 5 plus 8 plus blah blah blah, or I should say dot 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 plus 101. Okay. First thing, let's find n, which is the number of terms. So the first term, a sub n is the first term plus n minus 1 times the difference. Well, here the difference is 3. You can clearly see that. 2 plus 3 is 5. 5 plus 3 is 8. So 3. So the last term we're talking about is 101. And the first term is 2. Plus, we're trying to find what n is. We're trying to find n, the number of terms. So we get 33 goes into 99. Oh, you see how my brain was working there. It's 33 is n minus 1. So n is 34 terms. Okay. So we just found the number of terms in this series here. 2 plus 5 plus 8 plus dot 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 plus 101. So there's 34 terms. Now we got to find the sum. All right, we can do this, guys. Here we go. So we just proved in the last, in number 3, we just proved that the sum is going to be half times the first term plus the last term times the number of terms. We just showed that there's 34 terms. So we real quick just do a little math here. So 2 goes into 34, 17. And I'll tell you right now, I've already done this number out. You could throw it into a calculator. It's 1751. So the answer is 1751. It'd be great if someone brought in some kind of trivia question or famous fact about the year 1751. That'd be cool. So we're done. We just found the sum, and we had to first find the number of terms, which was 34. Then we used the formula that we proved in example 3 to find that the sum is 1751. Okay, this last problem is tough, and I don't know if I'm going to have to extend the page. I'm going to try to write very clearly. We're going to go slow on this one. This is going to be a hard one. And you'll practice some problems like this in the next class in the problem set. Okay, it says the roots of 64x cubed minus 144x squared plus 92x minus 15 equals 0. I'm going to take a sip of tea here. Oh, that was embarrassing. Sorry. We're in arithmetic progression. It said in the notes the progression is the same thing as saying sequence. Find them, meaning the roots. Okay, let's call the roots, let's call them r plus d, and r minus d. So you have the difference. They're in progression. So if the first one's r, you can add d. You could also subtract d. So now let's see what we remember about the sum of the roots. So the sum of the roots is r. The sum is 3r, and if you remember from our old good buddy Vieta, the sum is this number right here, positive, negative, positive, negative. So this is negative, it's negative, so 3r is 144, and you should be saying, no, you made a mistake. I know, we're supposed to divide by 64. I wanted to see if anyone was going to catch me here. So you have to divide by 64 to make the leading term here 1. So when you do a little bit of quick math, you get that r equals 3/4 when you divide by 3 and simplify. So we just found one of the roots. It says find the roots. Well, we just found one of them. One of them is 3/4. So there's, we're almost done. Although I shouldn't say that. There's a decent amount left to go. So now let's look at the other thing we always used to do with the roots was the product. Okay, the product so the product is this, and we look, the product is always the last term, so it's going and it should be minus, so it's going to be 15 over 64. And oh, I wanted to put in. Sorry, I just got confused there because I was going to start singing a Paul Simon song. Old friends sat on their park bench like bookends. Our old friends here are difference of squares. We cannot forget about difference of squares. So our old friends here, difference of squares. So I didn't know if I could set that one up. So ask your parents; they'll tell you who Paul Simon is. Okay. So now r squared minus d squared times r is 15 over 64. We already know what r is. R is 3/4. So we can come up here and say this. Divided by r. So r we know is 3/4. So if we divide by r, isn't that going to be the same thing as multiplying by 4 over 3? So that's going to be 5 over 16. So let's see. R squared minus d squared is 5 over 16. I did 3 into 15, that's 5. 4 into 64, that's 16. Okay. We already know what r is, so we can throw an r in right here real quick. Okay. When you solve this all out, you get something like 4/16. So you know that D is going to be plus or minus. Oh, it's our good little friend a half. My grandmother's from Charlestown, and that's how she talks, half and half. So people are wondering why I keep saying that. So D is plus or minus a half. We're done, guys. We want to find the roots. So root number 1, 3/4. Root number 2. Well, let's call this one root number 2. So 3/4, say plus a half. So 3/4 plus a half is 5/4. And root number 3, I'm going to get ahead of myself here, guys. Root number 3, we'll call the one r minus d. So what's that equal? 1/4. So the 3 roots, remember roots or zeros are the values for x, where if you you plug in for x, you're going to get 0. And in most cases, they're the x-intercepts, but if they're not necessarily, always x-intercepts if they're complex, but that's all in the past. It's things we've done in the past. For this cubic, the roots are 3/4, 5/4, and 1/4. That's a great review question. That was a tough question. All right, I hope I didn't hurt your eardrums with that singing. And oh, sorry. So if you would you mind just summarizing and writing down one question you have, okay?